Hi guys, today we're going to talk about section 6.5, operations with radical expressions. Let's get started. So our first example here is multiplication. Whenever we do multiplication, the main thing we want to recognize is that we're going to multiply the outside terms by each other. So 5 times 3. And we also are separately going to multiply the inside terms by each other. So outside times outside, inside times inside. So 15. And then we're going to have the cube root of negative 12 times 18. That turns out to be negative 216. A times a squared is a to the third. Remember, add our exponents. And then b to the sixth because we add our exponents. So what I would do from there is simply find my groups of 3 because my index is 3. So negative 216, if you recall, that's a perfect cube. So what I'm going to do is actually 36 times negative 6, 6 times 6. So I noticed something about this. I noticed, hey, these two are positive, but this one's negative. But when I'm referring to having the same number 3 times, I could make all 3 of those negative because negative times negative would give me that positive 36, and then I have that negative 6 over there. So I have a group of 3 negative 6s, so that comes to the outside. And if I wrote out 3 A's, I would have one group of A's. And if I wrote 6 B's, then I would have 2 groups of B's. So my answer to this one is negative 90A b squared. Go ahead and try this one on your own. All right, check your answer with what I got. See if you got the same thing. I hope you did. I think you would. All right, here's a little side note for you. In order to be able to add or subtract radicals, the radicals have to be like terms. And what like terms means is that your index has to be the same and the radicand has to be the same. So notice how both of these radicands are 3b and both of the indexes are 2. That would make those like terms. So for instance, if I wanted to add these together, I would have 1 square root of 3b plus 4 square root of 3b. That would give me 5 square root of 3b. I just add the outside numbers. All right. Let's go ahead and try this example. So you had to know what I just told you in order to do this. I'm looking at this and I'm thinking, hey, I can't subtract that because the radicands are different. So what I have to do is start simplifying first and seeing if I can make these radicands the same by any chance. So I'm going to go ahead and factor 98, and that would give me 7 square root of 2. And I'm going to factor out 32. And I'm going to do 16 and 2, and I did that on purpose because I know that 16 has a perfect square of 4 times 4. So I would have 4 square root of 2, but I don't want to forget that I had this negative 2 on the outside here. So I'm going to do minus negative 2 times 4, so that should be negative 8 square root of 2. So when I go through and subtract this, then I'm going to have 7 square root of 2 minus 8 square root of 2, which is negative 1 square root of 2. Notice I just subtracted those outside terms. Looking at this next example, notice that there's addition and subtraction going on. So let's see what we can do. Notice right now all my radicands are different. Let's see what we can do to make them the same. I'm going to start with 12. And I did the breakdown of 4 and 3, again, because I know 4 is a perfect square. I'm going to have a 2 square root of 3, except for one thing, this 5 outside. I need to do 5 times 2, and then square root of 3. So that's 10 square root of 3. On the next part, I'm going to do 27. That'll give me 9 and 3. Which 9 is good because, again, a perfect square. So I do need to make sure that I multiply by that 2 that's out there. So that would give me plus 6 square root of 3. Finally, I'm going to do 128, and I'm going to do 64 and 2, which 64 is 8 and 8. So 8 square root of 2 minus 8 square root of 2. I noticed something. I noticed that these first two terms, the red one and the orange one, they are like terms, and I can combine them together to get 16 square root of 3. But then this part in green, it has a radical of 2, so it's a little bit different. I can't necessarily combine that with anything, so this would be my final answer. On this next one, we're going to distribute. So just recall what distributing is. I have to multiply the outside numbers here. And remember, outside times outside, so 4 times 3 is 12. Inside times inside, so square root of 3 times square root of 2 is square root of 6. And I'm going to just keep going. I'm going to do this one. This 4 square root of 3 times negative 6 is negative 24 square root of 3. And then I'm going to distribute here. So I'm going to get 15 square root of 4. And then finally, I'm going to distribute here, and I'm going to get negative 30 square root of 2. So we're going to want to combine any like terms that we can, or simplify anything that we can. I don't really see any like terms, but I do see that the square root of 4, I can reduce that to 15 times 2, which is 30. Everything else, I don't have anything else to combine, so what I'm going to do is just write it out, and I'm going to have a really long answer. Okay. Go ahead and try this one on your own. Pause here. The answer here is 71. Hopefully you got that answer. This is just some rules about roots. The main one that I think is important is this quotient rule here. Basically telling you if I have a radical, I can split it into 2 radicals by putting the numerator on top, and then I would have the denominator on the bottom. So for example, this is number 11 from the practice that you have. If I had the square root of 11 over 9, what I can do is break it apart as the square root of 11 over the square root of 9. And then from there, I would have the square root of 11 over the square root of 9, which is 3. So that's why these rules can come in handy. So what we're going to talk about next is rationalizing the denominator. So that means what you need to do to remove radicals or fractions from the radicand. So if the denominator is just a square root of a number, then multiply the numerator and denominator by that square root. If the denominator is something other than a square root, a cube root, fourth root, any other root, an nth root, then what you have to multiply by is this here. So basically what I would do is subtract my index minus my exponent. You'll see what I mean in just a second. So here's the first example we're going to do with this. What I'm going to do is first split it apart as the square root of x to the 6th over the square root of y to the 7th. To rationalize the denominator, we want our denominator to not have any radicals there. So what I'm going to do is multiply this denominator by, notice that I have a square root. So I'm going to multiply the top and bottom by the square root of y to the 7th. So when I do that, I'll be left with, on the numerator, I'll have the square root of x to the 6th, y to the 7th, and on the denominator, I'll have the square root of y to the 14th. So let's go ahead and reduce those as we know how. So it is a square root, so I'm looking for pairs. So on the numerator, I'm going to just go down here. On the numerator, I'm going to have 3 pairs of x's. And with my y's, I'm going to have 3 pairs of y's, but with 1 y left under here. On my denominator, let's think about what I'm going to have. If I wrote out 14 y's, then I will have 7 pairs. And one thing that I noticed is that because this is multiplication, I have some of these y's on top and bottom, then I want to make sure that I reduce things that are the same on top and bottom. This would reduce. So I'm going to be left with x to the third square root of y over y to the fourth. Because remember, if I have exponents that I need to subtract them, 3 minus 7 would give me 4 left on the denominator. Okay, let's try this one. I want you to try this one on your own. All right, check my answer, see how it compares to yours. Let's try one where my denominator is something other than just something basic. It has two things here. I have a 5 and an x. I'm going to go ahead and rewrite this first as the fourth root of 6 over the fourth root of 5x. So if I go back to my rule, notice what it says. I have to do my index minus my exponent. So think about this. What I want to happen is for this radical to cancel out on my denominator. So my numerator, what I'm going to do is figure out what I need to multiply this denominator by in order for that to cancel. I need groups of 4, but right now I definitely don't have groups of 4. So what I'm going to do is multiply the numerator and denominator by, let's see, I have to do 4 minus this exponent right here of 1. So 4 minus 1 is 3. So 5 to the third. And then x to the 4 minus 1 is 3. 5 to the third, x to the third. So that's what I'm going to do on the numerator and denominator. 5 to the third, x to the third. All right, and the reason I'm doing this is because, of course, I need those groups of 4 in order to make this cancel out. So let's see what happens. So notice what I have here, 6 times 125. I got the 125 from 5 to the third. And then I have this x to the third. And look at my denominator. I got 5 to the fourth, x to the fourth, and I got that from 5 to the power of 1 times 5 to the power of 3 is 5 to the power of 4th. Same thing with the x's. Now I'm going to go through and simplify this out a little bit. All right, so notice what happened here. 750 x to the third, the fourth root of that, and over 5x, because that group of 4 5s and 4 x's come to the outside. And this next one is the last one that we're going to talk about. And notice that this one is a little bit different because I have to rationalize my denominator. And in order to do that, I have to multiply by the conjugate. We've done this before when we worked with imaginary numbers. What that means, the conjugate is going to just have the opposite sign here. So the conjugate of the square root of 5 minus 1 is the square root of 5 plus 1. And I'm going to multiply that on the numerator and denominator. So I'm going to take a minute to do that. The numerator really isn't too big a deal. I do have to distribute. The denominator is going to take a little bit more thinking because I do have to make sure that I distribute properly. The square root of 5 times the square root of 5 is the square root of 25. And the square root of 25 is just 5. Square root of 5 times square root of 5 equals the square root of 25, and the square root of 25 is just 5. Next, I'm going to do the square root of 5 times 1. That's just the square root of 5. Then I'm going to do negative 1 times the square root of 5, so negative square root of 5. So those cancel each other out. And then I'm going to do finally negative 1 times positive 1. So 5 plus 1 is 6. So let's see, I'm going to have 2 square root of 5 plus 2 on the numerator. And then on the denominator, I'm going to have 6. I notice one thing, that I can reduce all 3 of these by 2. So I want to make sure to do that. The square root of 5 plus 1 over 3 would be my final answer. All right, thanks guys.